Okay, we're going to deal with transformations now, another one. And this one we're going to deal with reflections. So there's two types of reflections we can do. So reflecting functions. The first reflection we can do is we can do a reflection across the x-axis, which is h at x equals negative f at x. And then we can do a reflection across the y-axis, and this is h at x equals f at negative x. Now, just like we had to do with the horizontal and vertical transformations, we have to be careful where the negative is in order to know whether it is a vertical, not vertical, a reflection across the x-axis or a reflection across the y-axis. Now, the x-axis reflection is the negative is not associated with the parent function. I mean, it's done after we do the parent function. We apply the negative after we've already done the parent function. And then reflection across the y-axis is that we apply the negative before we do the parent function. So let's look at a quick example here of this again. And let's look at f at x. We're doing with functions here. Let's look at h1 at x equals quantity negative x squared, and then h2 at x equals negative x squared. Now it's important to recognize which one of these is a reflection across the y-axis and which one's across the x-axis. So identifying the parent function for both of these is simply just x squared but then h1 at x, since the negative is done before the parent function, I'm applying the negative to the x before I'm squaring it. That would be a reflection across the y-axis. And then h2 at x is negative x squared, which h2, clearly the negative is being applied after I do the parent function. So h2 is a reflection across x-axis. So let's just real quickly look at the h2 graph here. The graph for h2 graph for h1 actually is going to be exactly the same, but we could do a reflection about the y-axis at some point as well here. But I first want to do a reflection across the x-axis here. And so I just want to go ahead and do that very simple one, and then we'll look at some other examples here. But let's do the very simple one of f at x, or it was h2 at x, I'm sorry, equals negative x squared. So again, the parent function is x squared, and then we have a reflection about y-axis. Now we're going to do these in a similar way here that we did before. So I'm going to go ahead and get my x squared. So this would be 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. So those would be my points, and then if you wanted to, just to remind you of the shape here, you can do some dotted lines here. So I got a parabola shape. Now reflection about it is basically the y values, reflection about, I'm sorry, this isn't y-axis, I said the wrong thing here. H2, it's a reflection about the x-axis. Got distracted about something else here. Alright, so if we do this reflection across the x-axis here, we literally take every point here and the y value becomes just the negative of it. So every point is just going to get flipped about the x-axis. Now the origin flipped about the x-axis doesn't move, so this point right here is going to still stay there, but this point would move down to here, this point, because all we're doing is making the y values negative. So the x values aren't changing, and this would go down to here, and then down to here, and then we would just sketch the graph here. And so that would be the reflection about the x-axis. And we could do an example reflection about the y-axis, but we will when we look at some other problems here. So now typically we don't just have a reflection present, we typically have a reflection present with some other transformations. So let's look at h at x. Let's not start with the one I was going to do here. Let's do this one here. H at x equals, we'll do the negative absolute value of x plus 2. Now, I know we didn't talk about the parent function of absolute value, but it's a pretty straightforward one, and we'll look at it here in a second. But let's identify here again all the things we got going on. Parent function is the absolute value of x, and then we have a horizontal shift left 2, and then a reflection about the y-axis. Now, you can think somewhat of these as somewhat order of operations, but we have to be careful because we'll see here, especially when we get to the x-axis or y-axis reflections here. And I said reflection about the y-axis. I am getting all twisted up here. I apologize. This would be a reflection about the x-axis because the negative. I should remind myself the rule here, right? Go all the way back to the top and say, hey, if the negative is outside the parent function, it's reflection about the x-axis. If it's inside the parent function, it's about the y-axis. And clearly this negative is outside the parent function, so it's a reflection about the x-axis. Alright, so let's look at the graph. Alright, so first we should sketch our parent function, which absolute value is pretty straightforward. As I said, we didn't talk about it in the parent function section, but it looks just basically like a V. And so that is, I guess I didn't do this with dotted lines. It's not a big deal, but I will be consistent here. So if I do the dotted lines instead, there we go. But now we're just going to still do the same thing we did with the other transformations. We're going to apply the transformations, and again you have to apply them in the correct order, and we'll look at another example. Maybe we'll look at another absolute value example here, just to illustrate what we mean by doing them in the right order. So we first have a horizontal shift left 2, so I'm just going to indicate that, and I'm going to draw circles actually. 1, 2, so I've got horizontal shift left 2, 1, 2, 1, 2, that point 1, 2, and then 1, 2. So those blue circles are what would be if I just had the horizontal shift left 2. But then I also have a reflection about the x-axis, And so now I'll go ahead and fill these in with solid green ones, because then this is what we'd end up getting, because we reflect those blue circles across the x-axis, and we would wind up with this graph right here. Alright, so let's look at another absolute value here. And we'll do another reflection about the x-axis. Reflection about the y-axis you have to be very careful about when we have other transformations present. So let's look at h at x is equal to negative x minus 1 squared plus 2. And yeah, we're actually going to do we'll do another graph here in a second. We'll do a very similar problem, because it very much matters the order that you do your transformations in. And this example plus the next one will kind of illustrate that. Alright, so my parent function, of course, is just x squared. But then what do I have here? Well, let's look at the transformations I've got. I have got, inside the parentheses, I've got horizontal, right 1. Then I've got reflection about the x-axis. And then we have a vertical shift up 2. Okay, so let's go ahead and do our normal sketching that we do here with these. I don't know why this is not wanting me to move things. Alright, so parent function oops, that's not in the right spot. And then we'll apply the transformations. Now, it can get pretty messy with all of them here, so I'm just going to draw some tiny dots and then apply them. So I'm going to do horizontal with going to the right 1. So 1, 1, 1, 1, 1. And then we've got a reflection about the about the x-axis. So then I'm going to make these circles here. Circle, 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 circle. And then finally we have a vertical shift up 2. And so now I'm going to move these up 2. So that's there. This moves up 2, so this is right here. This moves up 2, so it's right there. Up 2, so right here. And here. And so then I can just sketch in the parabola shape now that I have. So that would be the example there. Now, we do have to be careful, as I said, depending on the order of operations here. And I want to do that by doing another quick example of this one. And then we'll do an example with a reflection across the y-axis. So I'm going to make one difference, one change here, and I'm going to write this as h at x is equal to negative bracket x minus 2 quantity squared plus 2. Or not plus 2, what was it? Plus 1. Actually, I had it right. It was plus 2. It was minus 1 here. X minus 1 plus 2. And so this is identifying horizontal, right 1. Then the next thing was up 2, and then it's a reflection. So let's see what we get when we do that. So we start with the same parent function. And then we're going to do horizontal shift right 1 and then up 2. So I can do those at the same time. So right 1, up 2. So that'd be right here. Right 1, up 2, right there. Right 1, up 2. Right 1 and up 2. And then right 1, up 2. All right. So those were they would be. Now I'm going to do my reflection across the x-axis here. So the reflection across the x-axis, this point would move down to here. We have here, and here, and here, and here. So if you compare these two graphs, they're both parabolas, but they are different. And this is, again, I'm kind of scrolling back and forth between the two. And if you look at the equations, it's, well, I've got a negative applying to everything, where here I only have a negative applying outside the parent function. So this is where I say the order of operations does matter, but it's just regular order of operations, but you need to do your transformations in the order that is given in the problem here. So the first one, the order was a horizontal right 1, then a reflection about the x-axis, then a vertical shift up 2. And the second one was a reflection, a horizontal right 1, then up 2, then a reflection across the x-axis. So it does matter the order that you do these transformations in. All right, one more example here with the y-axis. The y-axis one here, as I said, can be kind of tricky, especially if we are combined with a horizontal shift. So y-axis with a horizontal shift. What you want to do here with these is actually get them in the correct form in order to apply your transformations. So these are a little bit tricky, as I said, because you got to get them in the right form. What you want to do here is you want to factor the negative, and then this doesn't actually obey order of operations like you might think it would. Then we're going to factor the negative, and then we're going to apply reflection first, because it doesn't exactly follow order of operations. Then apply horizontal. So as an example here, let's look at the function h at x equals the square root of 3 minus x. So we're going to do a little bit of work here to start off. This would be the square root of negative x plus 3. So there's definitely reflection going across the y-axis because the negative is inside the parent function being square root of x. But then I'm going to write this as factoring a negative out, h at x is equal to the square root of negative x minus 3. So what we can see here is there's a reflection about y-axis, and then we have a shift 3 to the right. And what we'd end up getting with the graph here, doing it, plotting my parent function again. Come on. 0, 0, 1, 1, 4, 2. My parent function being that. Well, if I do a reflection first, I would get following blue circles because I'm reflecting across the y-axis. And then we're going to do a horizontal shift to the right 3 units. And this would be the graph here. Now, if you aren't careful, as I said, you won't get the right graph here. And that's why it can be pretty tricky with these. If we simply just went with the way the function was, negative x plus 3, you might be tempted to say, okay, well, I'm going to flip it across the y-axis and then go 3 units to the left. But that won't give you the correct one either, because if you did that one, you'd actually be starting here and going over. And you might be tempted to say, well, order of operations said you do 3 to the right first, but then if we do 3 to the right first, 1, 2, 3, and then flip it about the x-axis, we would get this one as well, this green one here. So the reflections about the y-axis are fairly tricky. The key thing is to factor it like we did here, and then just remembering that you do the reflection first, then you do the shift. Okay, and that will get you your correct sketches here. We probably won't see that too often, but it does show up.